In this video, I'm going to get my BMW motor running in the 60 series. And to do this, I cover all aspects, plumbing and wiring, which will show you what it takes to do a complete engine conversion when there are no parts available off the shelf.
5 teams, 5 unique builds. We've gathered a bunch of our great mates to take on Tasmania's toughest terrain, testing their skills, their rigs, and their resilience, all in support of men's health this Movember. This is Kincrome Buildwars.
I've been given a 30k budget to build a 4-wheel drive to take on some of Tassie's toughest tracks against some of the best 4-wheel drive content creators in the country. This series gives me an opportunity to show you what is possible on a budget if you're making absolutely everything yourself. Before we plumb and wire the engine, you need to have it mounted first, and I've already got that done in a previous episode, along with the pedal shifter computer, and that is the first build episode on my channel, so make sure you check it out if you haven't already. Let's hook into the conversion now. First off, we need a way to cool down the radiator. And to get air through the radiator, I need a fan. The 3F came with an engine-driven fan, and while some people swear by them, I've always found thermos work really well. I can wire it, so I have more control over when it comes on, when it turns off, as well as being able to manually override it to turn it off for river crossings. It's not out of the question to change the pulley setup to make an engine fan work with the N57 engine. However, it originally came with a thermo fan, and it's definitely an easier option to go down that route. If only we had some sort of way to mount the thermo fan to the 60 series radiator. Cue the CAD design. This fan shroud is designed to fit a 14-inch Maradyne thermo fan. It picks up on the existing bolt holes on the 60 series radiator and will be made from 2mm aluminium. We've got a bit of room to play with in the engine bay because the N57 is so small, so we were able to make the shroud 20mm deep, and in hindsight we actually could have gone a little bit deeper given how much room we have left over. Alrighty, let's fabricate this thing. And we're starting with part of a raw sheet of 2mm aluminium on the plasma table. Now that it's marked out, we're ready to add some folds. We had to remove some teeth so we could get all the returns done correctly, but we were still able to do it in the backyard on the pan brake. Once it was folded, I did some alley TIG on the ends just so it looked a little bit nicer. With the thermofan mounted, all we need to do is wire it. And the Fusion Fab standalone engine harness has a trigger wire for the relay, so it's actually pretty simple. This custom fan shroud took about 4 hours all up to design, fabricate, paint and install. It's probably got about $40 worth of material in it. The thermofan itself cost $240 RRP, but I got a deal off a mate who had one lying around for $120. Overall, the RRP on this is $880, but I managed to get out of it for $160, which is pretty reasonable. Throughout this video, I'm going to show you that an engine conversion is more or less just a plumbing exercise. The engine was running just fine in the X5, so there's absolutely no reason why it can't be made to work in the 60 series. Let's get onto the engine's induction system. This is a Snorkel from Ocam. It was $110 shipped to my door, which is insanely good value. I wonder how it's even possible for that price. I could have gone down the route of fabricating something, but if I'm honest, I don't really like stainless snorkels on 60 series. I like the forward-facing head because I think it's more period correct. Install's quite easy on this one. Drill a couple of holes and cut one big one using the template. All up, this took just over an hour to install, so if a shop were doing it, call it 200 plus the 110 for the snorkel, 310 all up RRP. Pretty reasonable, I reckon. Bob's your uncle, we won't drown a motor. Let's get on to the intercooler. We need to put an intercooler in this build to cool down the charge air. I've opted for a PDI intercooler because it's one of the more budget-friendly options available, and it does look like a good piece of kit. We could go about making our own intercooler, which would have been cheaper and a lot more effort, but we're on a time schedule with this build, so an off-shelf option really is the only choice. To fit this particular intercooler, there's a bit of trimming required. Then you've got to drill some big holes. We have to change the AC condensers. Well, I think this is actually series 1, and then this is a series 2 AC condenser. But you can see here, these ports are in slightly different spots, and this one's facing up, and basically to fit with the recesses in the PDI intercooler, we have to change to series 2. Another option could have been that I bought one off eBay and made some brackets, but this is budget builds. I managed to get this one for free off a bloke named Taj, and he just DM'd me saying he had one, so amazing news. This is zero cost incurred. Massive shout out to Taj for his help with this AC condenser. That's the intercooler all fitted up, and one thing we didn't film was the trimming required to get the grill fitted. Massive shout out to my mate Kai who helped me with this. The trimming wasn't particularly easy and it took a long time, and it was quite a dirty job. Just so you know, that's standard, and we've had to trim all of that out to get it to fit. And it was super hard to do on the bottom. Basically there was nothing left on those little fins. The intercooler was around $1,100, and with all the trimming required to fit it and mess around with the AC condensers, it took around 4 hours all up, bringing the total cost of it to $1,700 RRP. I need an airbox for this build, and while I could probably buy something off the shelf that would work, the cleanest way to do it is by making my own. Where do you even start designing an airbox? And the answer is by getting the minimum filter size required for the amount of power that the engine's producing. To do this properly, you'd need the mass flow rate data of the air, which I don't have because I haven't started my engine yet. But there are these air filter calculators online, and I'm honestly not sure how accurate they are, but it's a really good starting point. You basically just plug in the engine displacement and peak power and a couple of other variables, and it spits out the minimum surface area. Then you can pick an air filter to design the airbox around, which is what I've done here. I've always wanted to try making a panel style filter airbox, but the engine bay is better suited to a conical style filter airbox due to the inlet and outlet, and honestly, they're much easier and quicker to make. To make the airbox work, it ended up being a pretty simple design. A 4-sided box with a weld-on flange on the top and an inlet and an outlet. It will have a perspex lid with a water jet rubber gasket. Let's crack on and make it now. I'm really excited to announce a partnership with SigWeld, and they've sent me a bunch of new welders midway through this build. We're about to put these things to the test and make a bunch of custom parts for this 60. That's the airbox tacked together. I'll just check how it fits up in the engine bay before going any further. Using a sophisticated system of quick clamps and timber, I mocked up the position of the airbox, which looked to have plenty of clearance, so I could cut out some mounts on the plasma table and get them tacked into position once they'd been folded up. Next job was to plumb the airbox to the turbo inlet. First off, I tried using a 3-inch aluminium bend, however the radius on this particular bend wasn't sharp enough. The next option was to use a silicone joiner with a bit of straight pipe, which did look reasonably promising. Next step is to bead roll a bit of pipe where the air filter is going to clamp to. looking down at it now, and I think the best option is going to be to miter it to get it down to the air filter. There's not enough room for a little bend up there, unfortunately. Now I need a way to cut the miters cleanly. Recently, I've been lucky enough to upgrade my backyard setup, and there's a link in the description below to that video. I managed to get this BO62V bandsaw from Hare & Forbes. It features a swivel head to cut these miters perfectly. It's super easy to use. Check this out. I've done a lot of pipe work before with a grinder, and while it's possible, it takes a lot of time to get the cuts to meet perfectly. So I'm super glad to have this bandsaw in my arsenal. It really has made everything a lot easier and quicker for me. Shout out to Hare & Forbes for supporting me with this one. Once I'd tacked the two mitered pieces together for the airbox outlet, I decided to tackle the airbox lid. I didn't want to blow through the holes that I'd cut out for the nutserts on the plasma table with the TIG, so I decided to put the nutserts in first. I purposely undersized the holes for this, which meant I had to drill them out. As a result, you can see the problem I'm faced with. The lid had warped from the nutserts and couldn't be welded down like this. I came up with the solution of cutting out a large washer type thing on the plasma table, which would pull the lid flat, but also give me enough space to do an outside corner weld. Once the bolts were done up, it seemed to work pretty well, and I could crack on with the TIG. For all that TIGging, the airbox is looking pretty close now. One last thing, we just needed an inlet. So to get air from the snorkel to the filter, I'm gonna have to plumb from here into here, which means we're gonna have to cut a hole out of here. So out comes the plasma cutter. I've got the tiniest little bit of piping left before I have a fully finished intake system. I don't have any budget left over to go buy a 3-inch tube, so I'm going to weld them together to get me out of trouble. If you're enjoying my design, engineering, and fabrication style of content, it'd be amazing if you could subscribe to the channel and like this video. It'll help with the mysterious YouTube algorithm more than you know, which will in turn allow me to make more videos like this. This airbox took me pretty much 2 full days to design and build. There's quite a lot of work in it. Material wise, I pretty much had all the pipes lying around at home, and there might be $100 worth of aluminium in it. Shout out to Richie from RadFab and MRC Industries for cutting me a clear Perspex airbox lid and for water jetting a rubber gasket to keep it all airtight. I think the RRP for all the material used would be around $350 plus 16 hours of labor plus a $50 filter, bringing the total RRP for this custom airbox to $2,800. Now that we've got air from the snorkel to the turbo, we can start getting the air from the turbo outlet through the intercooler and to the engine intake. The first pipe is actually pretty easy. We're joining onto the BMW connectors using a Fusion Fab adapter, which you'll see on the other side. The turbo outlet to the intercooler didn't require any welding, just a few silicone joiners and a bent bit of pipe. It was very, very easy. Now let's do intercooler outlet to engine intake. because we deleted the original BMW intake, I had to weld in a new charge air temperature sensor, which is what I'm doing here. Quick little bead roll on each end and we're good to go. You can see the completed intercooler pipe and the new charge air temp sensor here. That's the whole intake system now complete, and I'm going to get it powder coated black. Raw aluminium looks good for about 2 seconds before it gets stained with dirt and mud and looks like garbage. So it makes sense to pay a little bit of money for this. Now that the full intake system is complete, all we need to do is plumb the fuel system, power steering and radiator before we can turn this car over. The total cost for the intercooler piping, I'd say, was around $500. I basically had all of the material lying around. It was pretty quick to do. It only took around 2 hours. And I think the RRP on the material, if you were to buy it all, would be around the $200 mark. So it's actually pretty reasonable. The engine needs a diesel supply to enable the bang part of the suck, squeeze, bang, blow cycle. The 60 series that I have is petrol, but I still want to use the same tank. All I have to do is drain the tank and adapt the lines to the X5 engine. Sounds simple, right? Under the car now, and we've got to drain the old fuel tank, get rid of all the petrol. This isn't going to be pretty, it never is. I have no idea how much is going to come out because the fuel gauges aren't working.
Yes.
It's not good.
Oh no!
Well, it's slowing down.
Oh.
I guess I'm really lucky. I've built a car in the past and I just have boxes and boxes of dash fittings, and I would say that they're not counted in the budget. Honestly, you couldn't sell this stuff if you tried, but I think I'm going to be able to plumb most of my fuel system. There are 2 bits that I've had to buy. So this is like a lift pump, and then this is a BMW fuel filter. That wasn't too expensive actually. But otherwise, I think I'm pretty covered. All right, I've just laid out what we're doing. We've got a fuel tank and an engine mounted, and now we've got to add a low pressure fuel pump and a fuel filter from a BMW X5 and then plumb it all up. Let me explain how we're going to do it. We've got to get the lines. Now they come up around here. These are the old existing lines for the 3F, and we've got to get them over to this side of the BMW. So we've got 2 over here, and Ash does sell like a barb adapter for these quick connects. We started by mounting the BMW X5 fuel filter in the engine bay. Once that was mounted, we could adapt the hard lines to a push lock style fitting.
So we are using my beautiful plumbing skills to cut this and literally join it with an olive.
So we've got a hard line to soft line adapter basically, don't we?
Correct. So we're going to obviously put this over here, but it's not playing ball with us, right? So something that would normally be a 5-minute job has just probably been the better part of 45 minutes trying to get this olive on and off properly because the lines are pretty old. Pretty much why plumbers' bills end up being expensive, right?
The plan was to mount the low pressure fuel pump on the chassis rail, and for that we needed a bracket. Filter was looking pretty at home on the rail, and I plumbed the rest of the system. But when I cycled the pump for the first time to see if the diesel would pick up from the tank, I immediately saw a problem. The diesel still looked like it was dirty and full of particulates post the BMW fuel filter. So I decided to add an aftermarket secondary fuel filter to prevent any damage to my injectors. This was around $250, but it would be worth every cent if it prevented a catastrophic injector failure out in the middle of nowhere. To mount this secondary fuel filter, we would require some sort of bracket, and you know what that means. I'd opted to use bolts as studs to make assembly of the filter easier, which means the TIG comes out to weld them on. You may notice that I use ratchets a lot on this channel, and you probably do too. Well, I've got some exciting news for you. Kincrome have just updated all their ratchets. They've pretty much been doing ratchets since the dawn of time, which translates to 3 million sold and 40 years of production. Why have they updated them, you ask? Well, here's your answer. With 90 and 120 teeth points, which form 31 new sizes and ratchet options. These have been designed by Kincrome with trade professional feedback. Trust me, they're good. Also, Buildwars is for November, so donate if you want to support a good cause. The secondary fuel filter was now mounted up, but a few weeks later I realised I needed to reroute everything because I could fit an exhaust down the driver's side, and that exhaust would be too close to the fuel lines for my liking, which meant replumbing the whole system again. George was thrilled. And all we've got to do now is bring an exhaust from that dump pipe up there all the way through here. I've got to reroute my fuel lines, but that's okay. We'll get it. I won't bore you with all the details, but basically we just rerouted the whole system and we had to make a 3D printed PCCF spacer in the process to space out the BMW fuel filter from the chassis so the lines wouldn't rub against the crossmember. Now on to the next fuel system problem. The first time I tried to fill up, I encountered a problem that the nozzle from the diesel Bowser wouldn't go into here. So what I'm going to do, you can see, I'm hoping that these are the spot welds where it is spot welded in. So I'm going to drill them and then I'll just plug them up with weld and that'll be job done. After a quick little cut and shut to get the restrictor out, I could now fill up at a servo, which meant my fuel system would now work and it was all complete. Now onto the final cost. All up, it took around 12 hours of labour, including all the custom design and fabrication work. So the RRP on the fuel system is $2,870. My price was $770. Not bad when you do it all yourself. It's time to plumb the radiator, and I'm going to use a stock radiator for a 60 series. It looks brand new now, but when I got the car, it actually had a split through it and I paid a radiator shop $220 to fix it up, flush it out and paint it, which I thought was extremely reasonable. A port here on the engine, and we've got another port there on the bottom of the radiator, a top port there, and that one there. And then we've got this mess of heater hoses, which I don't quite fully understand yet. And then we've got to run it into the heater core, which is up there. Here's what we're working with, some leftovers that I have in the shed, and we've also got the BMW hoses there. And we've got a couple of these joiners as well from a leftover project car. This is hopefully going to be free and we'll be able to stick to the budget. How are we plumbing this car?
Well, that's a very good question, Rich. So behind the scenes, Richard and I for a while have been always like, I've always been about ChatGPT and he's like, no, it's all about textbook and knowledge. They've actually said that the top port is the inlet side and the bottom port is the return for the heater hose. So it is here. Right, so they're giving us all this information, right? And then you'll also see a diagram here for us, Rich, because you love diagrams. And then they've got little instructions underneath it as well. So ChatGPT for the win.
We had a quick go at it and it looks a little bit messy, but it was free and it didn't count towards the budget. Long term, I'll go through the bins at my local auto stores and get more suitable hoses. For the heater, I've managed to just use a stock X5 line, and then for the return, which is this one here, I've just had to get a heater hose and we're going to have to tee into this. I've come up with a budget solution. Let's go have a look. There you have it, a DIY radiator hose to heater hose adapter. Don't worry, long term when I'm not worrying about budgets, I intend on fixing all of this up and doing a stainless steel heater hose to make it all neat. Alright, so one of the problems we have is the BMW has these plastic joiners for pretty much all of their connections, and we can't get a 3/4 or 19mm heater hose over it. And what they've done in the factory is use some sort of special tooling. We don't have that, so we have this pipe expander and some map gas, and we're going to make it work. We're on!
That was way too easy.
Something I really don't like about these engines is the plastic on the radiator ports. They obviously weren't designed for off-road use, and I would hazard a guess and say that they will fail after prolonged use off-road. If I had more time, I would machine up some fancy billet bits, but this build is a bit slapdash, so fingers crossed it doesn't come back to bite me. I genuinely had everything for plumbing the radiator lying around in the shed. It probably took around 5 hours all up, which seems like a lot, but we had to figure out how to do it, which hose went where, as well as making up some custom fittings. If you didn't have anything lying around, I'd say the cost of material would be around the $200 mark, so overall you'd be up for $1,170. I paid $220, which can be attributed to me doing everything myself and also me hoarding car parts. Okay, onto power steering now, and it can seem a little bit daunting because of the high pressure side. I've learned a few things from past conversions, and I started by getting the original hardline from the 60 series steering box and getting a hydraulic shop to braze on a -6 male AN fitting. We have to plumb the high pressure side from the steering box to the steering pump. I used a piece of wire to get a rough length for the high pressure hose. Then I went to a hydraulic shop, got them to give me a piece of hose with one end crimped, plus around 200mm more than I measured using the piece of wire. Once I confirmed the length in the car, I went back to the shop and got it re-crimped to the right length. That's the high pressure side done now, and I would recommend outsourcing to a shop who can spec the correct hose. The low pressure side is a little less daunting, but we have to mount the reservoir first. This is a Raceworks power steering reservoir. Their RRP is $179, however I managed to get one off Marketplace for $80. I've found a suitable spot in the back of the engine bay to fit it, if only we had some sort of way to make a bracket. We landed on a simple 2-fold bracket made from 3mm steel, cut and folded in my outdoor entertaining area. I've opted to weld in bolts from the backside to act as studs to make assembly easier. This particular bracket took us 1.5 hours of time to design and manufacture, and it cost $10 in material, putting its final cost at $240. Pretty absurd, right? But that's the reality of custom work. It does take a lot of time. With the power steering reservoir mounted, I could now run the low pressure side, which I ran through the factory power steering cooler, which is like a line at the bottom of the radiator. I didn't film any of it because it was pretty easy and honestly quite boring. The power steering all up took around 4 hours to plumb, and the high pressure side and that brazed fitting cost $150. The low pressure side hose and hose clamps cost $50. So all up, including that bracket and the power steering reservoir, the plumbing would be $909 RRP, but my price was $295. So that's everything plumbed with the exception of the air conditioner, which I'm running out of time to do. I don't have the time to plumb it up before Tasmania, so I'm going to blank it off. I'm 3D printing some bolt down caps out of ASA for the AC pump, and I'm blanking all the condenser fittings and firewall fittings with end caps and tape. When I get back from Tassie, I'll get it plumbed up, but at least for now, I won't damage any of the hardware or get dirt in the system. As promised at the start of this video, we can finally fire this thing up. This was actually done a while ago in the scheme of the timeline, somewhere in the middle of all the jobs I completed in this video. I was lucky enough to have Ash from Fusion Fab helping me with this. We had to make a few wires to the starter motor and alternator before we could fire it up. Monumentous occasion for the build. We're about to fire it up for the first time. So I've had Ash from Fusion Fab helping me today with it, and yeah, really excited about this.
It definitely has oil?
Definitely has oil. Yeah, I put it in last night. Pretty sure that noise is just air in the injectors, and the smoke is coming out of the bonnet because, well, there's no exhaust yet. We'll cover that one in the next episode.
So it's looking good.
It's looking good.
Yeah.
I'm wrapped. I can get to bed tonight and know that there's no issues with it.
That's the end of this build episode. Make sure you tune into TJ and Mac's channel tomorrow night as they build their epic GU Patrol.
Holy snapping duck shit.
The next video on my channel will be the last build episode of the 60, and I'll design, build and fit all the accessories under the sun to get the 60 Tassie ready.